All right, so now we're about to wrap up section 2.1. So I just want to point out a couple of things as we go away from it. So one is on page 61 toward the bottom, you have these properties of limits. So these are important. We will come back to them, but you don't need to spend time looking at them now. Just be aware that they're there. I'll sometimes point to them. So they work like this. If I have two functions and I know at the point C, I know the limit of each function, then if I add the functions, I add the limits. If I subtract the functions, I subtract the limits. If I multiply the functions, I multiply the limits. If I multiply the function by a constant, I multiply the limit by a constant. If I divide the functions, I divide the limits as long as I don't have something undefined. All right, so these are properties of limits. They're important, but they're also kind of intuitive and obvious. So we'll come back to them and I'll point to them at times if we need to. All right, next thing I want to point out is the very important step function that occurs on page 64. So you see this is labeled y equals int x. So that's the function. It's called the greatest integer function, or sometimes it's called the step function, or just integer function, or just int. So this function, basically what it does is the y value is the largest integer that is smaller or equal to the x value. So for example, when x is 1.5, the largest integer that is smaller than 1.5 is 1. So it stays 1 until we get to 2, and then it jumps to 2, and then it stays 2 until we get to 3, and then it jumps to 3. So it has these jumps. By the way, that has a name. It's called a jump discontinuity. We're going to talk about it a lot. This function is going to come up a lot. The integer function, or the greatest integer function, or the step function. The graph is here on page 64 if you want to look that over. All right, so that's going to come up in the homework. It's going to come up on test questions. So we want to know about that function. Greatest integer function. All right, next is time for a sandwich, because it's lunchtime. The sandwich theorem. All right, so the sandwich theorem is a weird little theorem that doesn't seem like it would be that important, but it turns out to be critically important for certain things that we're going to see later. So I just want to point out that it's here on page 65. All right, so if we ever talk about the sandwich theorem again, it's on page 65, and it looks like this. This is the picture for it, and basically it's saying we have three functions. And the thing about the three functions is that one of the functions is in the middle. So it's a Goldilocks and the Three Bears type thing. This function is too small, this function is too big, this function is just right. This function is in between these two outer functions, okay? So, if we look at the limits of the functions, all right? So even though we might not know what the function f is, we can say what the limit is if we know what the limits of g and h are. So typically what's going to be going on here is that g and h are functions that we know something about, and f is something that we don't know the limit of, all right? But what we do know about f of x is it has to be in between g and h. So the picture is here, g and h are bounding the outside, and f is stuck in between them always less than or equal to g and f. But all three of those functions have a hole at c. Now, they wouldn't have to, but I think it's clearest if we say all three of those functions have a hole at c. Now, f might be a function that I don't know anything about, but if I know the limit of g and h, and I know that both limits go to a certain value, L, then I know that the third function has to go to that same value. So we'll see how that is important later. For now, just know that it's there. It's a sandwich theorem. It's called the sandwich theorem because g is a piece of bread, h is a piece of bread, and f is peanut butter. That's the sandwich theorem. All right, now, we're ready to start looking at some of the assignments, some of the problems that you need to solve in the book. But I need to point out an annoying thing first. So this book has a quick review, has 10 questions, and then it has exercises, and it has a whole mess of questions. So that wouldn't be confusing, except for the fact that sometimes the quick review and the exercises are on the same page. And when that happens, what happens is on page 84, you have two number 1s, you have two number 2s, you have two number 3s. So if I assign you to do page 84, number 1 through 10, am I telling you to do these ones up here, or am I telling you to do these ones down here? Well, I'm going to answer that question once and for all, now and forever for this class. We never do the quick review. If you ever are doing an assignment and you're looking at this light blue quick review, stop doing that. Go back down here to the exercises with the dark blue. That's where the assignment is. So if I give you page 84, 1 through 10, it's these ones. It is not these ones. Okay, so that preliminary out of the way, we can start looking at some of these problems in our next video.